I'm going to do a few examples here for you about using the area of a triangle formula that we learned about in class, so that you could do watch a few of these examples and work on a few practice problems that I've posted and be ready for your take-home quiz. So remember that our area formula that we developed in class was 1/2 a times b times sine of c. Now remember that really all we need to do is the product of two sides and the included angle. In this particular case, that's the letters match up for what we have in this particular picture. This would be A, because that's the side opposite A. This would be B, because that's the side opposite angle B. And C here is the included angle. But remember, it doesn't have to be A, B, C exactly. It just needs to be two sides and the included angle. So for this particular problem, then we would have 1/2 times 13 times 23 times the sine of 98 degrees. And now we can come over to the calculator and type this in. So we have, I'll see if I can move this over a little bit so we can actually see the screen. So we had 1/2 times 13 times 23 times the sine of 98 degrees, and we get 148.0451. So that's 148.0451. All right. So that would be our area for this particular problem. Let's do one that's a little bit more complicated, because we don't, the triangle that we have here, we're given two sides and an angle, but we don't have the included angle. Notice what we are given B, and we are given A, but we're also given angle A. That's 25 degrees. So it would be great if we could find C, because that would be the included in between those two sides. So, but I don't have the side opposite C, but I can find angle B here. I can find this one. And then once I know this one, I can find angle C. So let's do that first. Let's use sine, I'm going to call it beta, over 11 is equal to sine of 25 degrees over 7. So sine of 25 degrees times 11 over 7, multiply both sides by 11, that's sine of beta. If I just cross multiply and then divide by my 7. So beta will be equal to the inverse sine of all that. And if you prefer, you can type this in one step at a time. I prefer to do it all at once. So inverse sine of 11 times sine of 25 divided by 7. Make sure I have my parentheses all in the right spot. That gives us that our beta is about 41.6144 degrees. Okay. So now that we know beta, we can figure out what, if I call it gamma, that was a letter we used in class. I know that gamma is going to be 180 minus 25 minus the 41.6144. So I can do that on the calculator. I'll add the 25 and subtract the 180. I know that sounds backwards, but it gives me the negative of what we want, 113.3856 degrees. And now we're ready to finish off the area, because now I found my included angle. So my area will be 1/2 times 11 times 7, product of the two sides, times the sine of the included angle, which we just found was 113.3856 degrees. And now if we use the calculator, Let me make this answer positive, so I'll multiply by -1. Not that that really matters, we can figure it out otherwise, but just to make it look like what we have in our expression over here. 1/2 times 11 times 7 times sine of the angle. So I just use the previous answer button and get 35.3374 is our final answer for that one. Again, notice we had to use the law of sines here to give us the angle that we needed. So we got, well, actually we had to use the law of sines and then our knowledge that the angles added to 180 to get the angle that we needed. There, you could have figured out this other side if you really wanted to use one of the other angles. But once we found this angle, we might as well go ahead and just get this angle and figure out the area from there. So the problem is just asking us to find the area. All right, let's do one more, but let's look at one that uses the law of cosines. I've got lots of sides here, but no included angle. So I can figure out this angle, call it gamma. Remember when we use the law of cosines, if we have all three sides given to us, we like to find the biggest angle first, which is across from the biggest side. So we would have 10.5 squared equals 5.9 squared plus 9.6 squared minus 2 times 5.9 times 9.6 times cosine of gamma. 10.5 squared is 110.25. 5.9 squared, oops, wrong button, squared is 34.81. 9.6 squared is 92.16. And then if I do 2 times 5.9 times 9.6, we get 113.28. That still times the cosine of gamma. We need to subtract these two values to the other side. So we 110.25 minus 34.81 minus 92.16 gives us negative 16.72, and the negative is important here. Both of those have a negative, so if I divide, our cosine of gamma is approximately, let's divide that by 113.28. Should have divided it by the negative, so I'm going to make it positive 0.1476. Rounded to 4 decimal places. Now we do our inverse cosine. Inverse cosine of the previous answer gives us, oops, I forgot to make it positive. Sorry, let me go back up here again. Let me grab that number, make it positive, and then do the inverse cosine. Apologize for that. This is 81.5122 degrees. Now we can get our area because we have the included angle. Our area will be 1/2 times the 5.9 times the 9.6 times the sine now of this 81.5122, and using our calculator, 1/2 times 5.9 times 9.6 times sine of the included angle gives us the 28.0098. Notice that I did a lot more work than I actually had to do here. I wanted to do this one just to give you a little bit of a reminder of the law of cosines, because sometimes you still have to use it to be able to figure out the angle. Certainly that's something we'll need to do. You did it on your take-home test. But this one we could have also used Heron's formula. Remember that Heron's formula says that the area is equal to the square root of the semiperimeter times the semiperimeter minus each of the sides of the triangle, the product of those things. So the first thing we can compute here is the semi-perimeter, which will be your 10.5 plus the 5.9 plus the 9.6 all over 2. So go over to the calculator, 10.5 plus 5.9 plus 9.6 gives us 26, and divide that by 2, we get 13. So now we can plug that in. Square root of 13 times 13 minus 10.5, 13 minus 5.9, 13 minus 9.6. Multiply all those together, and then take the square root. So I'll do that all at once. 13 times 13 minus 10.5. Oops, 10.5, not 1.05. Times 13 minus 5.9 times 13 minus 9.6. And we get that 0098 again. So, got the same answer both ways, and of course Heron's formula here was shorter, but I wanted to again, like I said, I wanted to remind you of the law of cosines. So hopefully this gives you a couple of examples of how we can do area, and again, we have those practice problems that you can do as well to remind you how to do that as well.